Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group Visionary Network. So next slide. So before we started with our presentation, I would love to introduce our group members first. My name is Karul Imran bin Nazari and my student ID is 2023 89 90 and 68. So next.
Okay, my name is Muhammad Zarfida bin Zamri and my student ID is 2023 165 215.
My name is Umar bin Sharil. I am 2021 839 968.
My name is Hasri Sapaliwe Makno. My student ID is 2023 190129.
So this is our content. So which is in our presentation, we will explain about the objective, input data, separation of data, training phase, test phase, and lastly is the conclusion. So on the next part, I will pass to the next presenter, which is Hazril.
Okay, thank you. For the objective, convolutional neural network (CNN) are used to learn a model to precisely recognize and classify objects from a group of pictures. A dataset of identified objects with a name can be applied to each image that will be used to train the model. Each object has their own category or corresponding class that will help the model identify it. Due to its ability to recognize and extract characteristics from image and base prediction on those characteristics, the CNN architecture is particularly ideal for this purpose. The final goal is to utilize the trained model to correctly identify items in previously unseen photo. Next, for the input data, image of stationary, specifically an eraser, glue stick, paperclip, pencil, and ruler compose the project input data. There are 500 samples in all in the data set, 100 samples in each of the 5 categories of paperclip, eraser, glue stick, pencil, and ruler. Every image has a variety of characteristics including size, shape, color, and texture. The machine learning model will recognize and categorize the stationary type based on those characteristics. Next for the list of dataset. Next, we have four dataset, which is dataset of eraser, dataset of glue stick, dataset of paperclip, and dataset of pencil. For the next slide, I will pass to the Muhammad Zalik.
Okay, thank you, Hazril. So let's take a look at separation of data. First, 2 sets of data have been created specifically for this project, which is training and testing. From this project, 20% of the data is used for testing, while the remaining 80% is used for training. The machine learning model will be trained on the training set, and its performance will be measured on the testing set. Second, by using the training set, the machine learning model will be trained to be able to understand the relationship between the data of characteristics and labels. The trained model's effectiveness will be assessed using the testing set by contrasting its predictions of the photo with the actual labels of the data. Third, since the model is being assessed on the data that it has never seen before, we may obtain a more accurate assessment of its performance by utilizing a multiple testing set. This makes it a greater possibility that the model will generalize effectively and produce precise prediction on fresh untested data. So, for the next, I will pass it to the Khairul Imran.
So hi, for the training phase, we got 10 experiments that we have done. So let's take a look on the first experiment. So this is the code for the first experiment. Alright, next slide. So for in the figure 7 of the experiment 1, we got 60% of validation accuracy, and it took 30 seconds to complete the first experiment, which is the max pooling layer is 2, the max epoch is 4, learning rate is 0.01, result validation accuracy is 60%. So let's move on to the next experiment, which is second experiment. This is the code. So next slide. So based on the experiment we have done, we got 70.67% validation accuracy. The increased accuracy is because of the difference of maximum approach from the first experiment affects the accuracy result. Hence, the maximum approach from the first experiment is 4 approach. For the second experiment, it increased to 8 approach. So it takes 2 seconds to complete the second experiment, which is we got the result validation accuracy to 70.67%. Right, next experiment. Alright, this is the third experiment we have done. So this is the code. Let's move on to the next slide. So for the third experiments, we changed the convolutional 2D layer into convolutional 2D layer, which is 432 padding seams. So the result of the changes that we got is 78% validation accuracy, and it takes 2 seconds to complete the third experiment. So next slide. So this is the fourth experiments code. So next slide. So in the conclude, the experiment 4 is that we changed the convolutional 2D layers into convolutional 2D layers for 16 padding seam, and the result that we got is 91% validation accuracy, and it takes 2 seconds to complete the fourth experiments. Right, next. So the fifth experiments, this is the code, and next slide. So for the fifth experiment, we changed the convolutional 2D layers into convolutional 2D layers for 16 padding seams, and the convolutional 2D layers for 32 padding seams. So the result that the changes that we have done is we got the 86% validation accuracy, and it takes 3 seconds to complete the fifth experiment. Next slide. So this is the sixth experiment. This is the code. Alright, next. So based on the figure 12, we can conclude that for the 6 experiments, we changed the convolutional 2D layers into convolutional 2D layer for 8 padding seams, and convolutional 2D layer 336 padding seam, and the result we got is 93% validation accuracy, and it takes 3 seconds to complete the 6 experiments. Alright, next. So this is the 7 experiments code. Alright, next. So for the experiment 7, we changed the convolutional 2D layers into convolutional 2D layers 316 padding seam, and the result, the changes that we got is 89% validation accuracy, and it takes 2 seconds to complete the 7 experiments. Alright, this is the 8th experiments code. So this is the figure that we can see that we changed the convolutional 2D layer into convolutional 2D layer 38 padding seam, and convolutional 2D layer for 16 padding seam. So the result that the changes that we got is 74% so validation accuracy, and it takes 3 seconds to complete the 8 experiments. So next. So this is the 9 experiments code. Alright, next. So based on the experiments 9, we changed the max pooling 2D layer into max pooling 2D layer 3 stripe with 2, and the result, the changes that we got is 90% validation accuracy, and it takes 2 seconds to complete the 9 experiment. So lastly is the 10 experiments. So this is the code. Okay, so in figure 16 we can see that the experiment 10 results, which is we change the convolutional 2D layers and max pooling 2D layer into convolutional 2D layer with 8 padding same and max 2D layer 5 stride 2. So the result, the changes we got is 93% validation accuracy, and it takes 2 seconds to complete the 10th experiment. So on the next part, I will pass to Zareb for explaining the testing phase. Thank you.
Okay, thank you. So for the testing phase, we have concluded about 5 test phase. So this is a testing phase code. So let's next for the figure 17, it showed the testing picture. For the testing phase, we got 84% validation accuracy. The changes in convolutional 2D layer and max pooling 2D layer may affect the accuracy. From all the 10 experiments, the testing got the highest accuracy, and it takes 3 seconds to complete the training. To test out the accuracy, we give the AI 4 pictures of different stationary types and let the AI figure out the type of stationary. Next, this is the example of test 1 coding. So next, figure 18, test 1. For the first test, we choose a picture of a pencil to test out the accuracy. The result from the figure 18 show 42.6% and can conclude that it is successful first test. Next, this is the sample of the test 2 coding. So for the test 2, for the second test, we choose a picture of paperclip to test out the accuracy. The result from the figure 19 show 94.2%. We also can conclude that it also successful second test. For this is coding for the test 3, and the figure 20, we choose a picture of an eraser to test out the accuracy. The result from figure 20 show 57.7% and conclude that it is also successful third test. For the first test, this is the coding. Next, we choose a picture of a ruler for the first test to test out the accuracy. The result from figure 21 show 100%. We can conclude also that it's a successful test. And lastly is this test 5 coding. Next, for the figure 21, the last of the test, for the fifth test, we choose a picture of a glue stick to test out the accuracy. The result from figure 22 show 99.2%. We can conclude that it is a successful fifth test. So for the conclusion, I will pass it to the Umar.
Alright, thank you, Zareb. Now I talk about conclusion. According to the experiment, the maximum accuracy is 93%, which obtained from experiment 6 and also 10, while the lowest accuracy is 60% is obtained from the experiment 1. The starting rate, max pooling to the layer, convolutional to the layer, and max epoch of the two is different. The more max epoch, the more accurately AI can distinguish between images. With average validation accuracy of 82.47%, the range of a validation accuracy was 60% until 93%. This demonstrates that CNN can distinguish between 5 different types of stationary images, even while AI cannot yet distinguish between distinct image as well the human can. It is used as is starting to increase as the AI technology develops. So the 93 accuracy is the maximum. That's all from our group. Thank you.